Hello everyone. So welcome to the series Working with Snowflake. So in this video, we delve into the architecture of Snowflake and how it is different from on-premise data platform. So whether you are a beginner or an expert, I aim to provide you valuable insights, tips, and strategies to help you improve your understanding with Snowflake. So let's jumpstart and explore architecture of Snowflake together. Snowflake has a unique multi-layered architecture which allows better performance, scalability, elasticity, and concurrency. Snowflake layers are physically separated, but they are logically integrated. So, which will enable you to uh, run your workloads on speed and it supports all types of workloads. So, in this session, we will see how Snowflake uh, three-tier architecture works and how it is unique from on-premise data platform architecture. So before diving into the architecture of Snowflake, let's look at the architecture of one of the on-premise database that is SQL Server. So SQL Server, it will be installed in any of the operating systems such as Windows or Linux. So the SQL Server, where we install the SQL Server, is the same place where our storage engine or the database is stored on the same service disk. And also the queries that we run will be processed on processed on the usage of using the RAM or processor or host of the same server. So if you want to scale, then there will be a lot of work that needs to be done and it will consume a lot of time. So on the other hand, let's look at the architecture of Snowflake and how it is easy to use. Snowflake is a self-managed, self-service data platform, which is far more flexible than traditional databases. So it is not built on top of any of the database technologies like Hadoop, etc. Snowflake combines the complexity of a new SQL query engine. So it automatically improves the performance of the SQL query that you run on Snowflake query engine. Also, Snowflake provides all the functionality of enterprise analytics database along with additional special features and unique capabilities. So what do we mean by self-managed service? So it's like you don't need to install any software or any hardware, whether it be virtual or physical. You don't need to configure anything or manage. You don't need to perform any maintenance or management, upgrades, or tuning. Everything is handled by Snowflake. So it is a truly self-managed service. So you just need to create your account and set up some roles and permissions on the database like data security and start using the Snowflake. So that is how this self-managed service. So we have seen how the architecture of on-premise database is. Um so let's see the three-tier architecture of Snowflake, where each layer is separated, but they are integrated logically. So that's what makes Snowflake a powerful architecture. So the Snowflake's architecture is redesigned to be processed, uh, re-architected so that it can be easily used on cloud and also it can be uh, easily scaled as per the needs of the workloads. So as you can see, there are three layers. The central layer is the storage layer, and this layer is shared. So all the resources like compute and cloud services. So this layer can be shared across resources. That means this layer will not move. It will stay constant. I mean, stay in the particular storage area. What happens is uh, users from different availability zones or different, uh, I mean, roles and permissions and accounts can access the same data without moving the data to different locations. Uh, as compared to the traditional data warehouses or databases, we move the actual data. So here we don't move the actual data. It resides on the central location, and we just query it using the cloud services. So Snowflake's its architecture is a combination of traditional shared disk and shared nothing database architecture. So what does this mean? So what happens in the shared disk architecture? uh, Data is shared from the central repository and it is stored there. That will be accessed from that will be accessible to all the users who have access to that database. So similarly, Snowflake maintains that shared disk architecture, but the the additional feature or architecture of Snowflake is it has a shared nothing architecture. So what does Snowflake do is Snowflake processes queries using massively parallel processing compute clusters. So it's a combination of clusters of computers where each node in the cluster stores a portion of entire dataset locally. So this approach offers data management simplicity of shared disk architecture, where managing data will be easy, but with the performance and scale out benefits of shared nothing architecture, it, you know, it can massively run the queries uh, with high performance and speed. So let's look at each of these layers in detail. So on the top, we had cloud services layer. So Snowflake can work with popular three cloud services, which is Google Cloud Platform, Azure, and AWS. So you can have your cloud services account in any one of these cloud services, and once you have that account, you can log into the Snowflake with your cloud services account. So what does cloud services do here? The, the cloud services layer has a collection of services that coordinate activities across Snowflake. So these services tie together all the different components of Snowflake in order to process user requests from login to query dispatch, like from start to the end. So the cloud services layer also runs on compute instances provisioned by Snowflake from the cloud provider. So services which are managed in the cloud services layer is authentication. Like when you, uh, if you want to log into the Snowflake server, infrastructure. So what should be the infrastructure management? Then metadata management and query parsing and optimization, and also the access control. So these are the various services that are managed under cloud services. So next we have query processing. So here the query execution is performed in this query processing layer. So you can see here there are a different virtual warehouse. So it is a cluster of one warehouse is clusters of computers. So it uh, each virtual warehouse is a compute cluster composed of multiple compute nodes allocated by Snowflake from cloud provider. So by using cloud services, it creates a virtual warehouse where it will have a multiple compute nodes. So when you run the query, it will run parallelly in multiple nodes, and each warehouse is independent compute cluster that does not share compute resources with another virtual warehouse. So it doesn't share its resources with another warehouse. So you can create number of virtual warehouses in Snowflake. So as a result, what happens? Each virtual warehouse has no impact on performance or, of another virtual warehouse. So it's independent. So you can run as many workloads as you want. Let's look at another layer, that is data storage. So when you load data into the Snowflake reorganizes the data into its internal optimized compressed columnar format. So if you don't know what is columnar format, I can uh, I can explain you in another video, or you can look up in the Google. So databases are generally built in row based format or column based format. So Snowflake optimizes the data into columnar format, and Snowflake stores this optimized data in cloud storage. Also, Snowflake manages all the aspects of how this data is stored, like the organization of the data, the file structure, the compression, the metadata, the statistics, and all other aspects of data storage is handled by Snowflake. So the data objects stored by Snowflake are not directly visible nor accessible to us. So they are only accessible through SQL query operations run using Snowflake. So there are various SQL queries that Snowflake or you can find online on Snowflake community. So if you want to see the internal details of a Snowflake, like how your queries are running, how they are stored, what query has run at what time. So you can run queries and see by using those specific queries. So this was in brief about data storage. So what does this mean? That a lot of work that DBS do in SQL Server will be reduced. Like almost everything is managed. The database administrator's work is managed on the Snowflake. So there is no management required. So by this, Snowflake is a complete self-managed cloud data platform. So Snowflake supports multiple ways to connect to the service. So you can connect from SnowSQL, a client-based tool of Snowflake. You can directly log in to the Snowflake account using a web-based portal, or you can use ODBC or JDBC connections, use Tableau or Alteryx or other applications to connect to the Snowflake. Also, there are native connectors like Python, Spark that you can use to connect to Snowflake, and also third-party connectors that you can use to connect to Snowflake. And this wraps up our another session working with Snowflake. So I hope you found this video informative and enjoyable. So if you have any questions or suggestions for future topics, please let me know in the comments below. And do not forget to subscribe and hit the notification bell to stay updated on our upcoming videos. So thanks for watching, and I'll see you in the next video.